There that is. Okay. Please mute yourself and stay muted through the whole session, if you will. We're going to record this presentation. So if you wish, you can stop your video during that recording. And it may be that we will ask people to stop video to help with bandwidth. If we have more people join us, it's going to be a large number of people tonight. Also, if you have a question, please use the chat. And the questions will be asked to Dr. Beal in the order that they came in. So at this point, we are going to start recording the session. And I'd like to introduce the moderator for the session. It's our honor to have both Dr. Beal and Dr. Stephen Kelly. Dr. Kelly has been an instructor for Sunrise Senior College with some very popular courses. He is a former journalist and a US diplomat, and he's been affiliated with Duke University for the past decade. And he's most recently, he's been there as a research scholar. And he's been coming to his Jonesport house for 20 years. And I think he's very fond of it because he's always talking about it when we have our Zoom meetings. So I'm giving this meeting over to Dr. Stephen Kelly.
Thank you, Ann. You've promoted me. I never did get that doctorate. I just didn't have the discipline or the interest, I guess. But thank you very much for that very kind introduction. We're very lucky tonight to have Dr. Brian Beal with us. Probably many of you know him much better than I do. I've gotten to know him in connection with this presentation. And it's hard to imagine somebody who's better qualified to talk about shellfish in the Gulf of Maine. Not only is Dr. Beal a Jonesport native, we were talking earlier about how he graduated from high school when the last of the herring sardine factories closed down in Jonesport back in 1975. He earned money clamming and lobstering to help pay for his tuition. He got his bachelor's in biology from the University of Maine in Machias in 1979. And then he wisely went south to warm up a little bit at the University of North Carolina at Chapel Hill, where he got a master's degree in marine science. Then he came back to Maine, to Orono, University of Maine at Orono, for his doctorate in marine bioresources. And then nearly 30 years ago, he came back to UMM to teach marine ecology and to do research. Along the way, he helped create this research facility now located in Great Wass Island that is part of the Downeast Institute, where he's currently the director. And if you visit him in that office where he's sitting now, you can't quite see it, but in the back there by the filing cabinets, there's clam rakes, there's various muddy traps, there's boots and other paraphernalia that tells you that this is a real hands-on researcher, somebody who's devoted his life and his career to shellfish in the waters off of Washington and Hancock County. So thank you, Dr. Beal, for sharing your expertise with us tonight. We're going to have a lot to discuss. What's going to happen to, or what is happening to the lobster population? Where have all the mussels gone? And will this cold winter help kill some of those green crabs? The questions that are on everybody's mind. But before we get to those, I was hoping that you could tell us a little bit about the Downeast Institute. What is it? How's it organized? There's been a lot of neat construction out there lately. So for some of those taking part in this call who are not as familiar with the Downeast Institute, perhaps we could start with you just giving us a little briefing on what it is and what it does and where it came from.
Sure. Can everybody hear me okay? Yeah, so what I've done is to put a little PowerPoint presentation together. And I know I've got probably more slides than I should, and I'm probably going to go through them pretty fast, but Steve, you also don't know that I had a minor in history at UMM as an undergrad, and history is a very important thing to me. So I'm going to share a little bit of the history of how the Downeast Institute got to be where it is. And I'm going to start right at the beginning. So I'm going to share my screen, and let's see if I've got this one right there. Okay, can everybody see that screen okay?
Yeah, looks good.
Okay, so I'm a professor of marine ecology here at UMM, and as Steve said, it's my undergraduate alma mater. I've actually been teaching here since 1985, so this will be my 37th year coming up in May. Let's see. So my screen is jammed. That's a nice place to start. And I'm not sure what to do. So I'm going to stop the share. And I'm going to go back here. I'm going to escape from that. I'll come back here and try another share screen opportunity. And let's see if this one does a better job. Let's see. Go. There we go. So I'm going to be talking about the Downeast Institute, and what you need to know is that its history is basically a history of what we've done and what we've learned about with soft-shell clams. But to start, let's talk a little bit about the mission of DEI, and that is to improve the quality of life for the people of Downeast and coastal Maine through marine research, marine science education, and innovations in wild and cultured fisheries. And the vision is that the work that we do at DEI will generate new knowledge of the marine environment or ecosystems for all who depend upon it. DEI's beginning started in 1986 when I was able to write a grant, my first federal grant to the National Oceanic and Atmospheric Administration's National Coastal Resource Research Institute out in Newport, Oregon. And it was a project that had 7 primary targets. One of them was to stimulate the economy. What we wanted to do is to create a shellfish hatchery to produce soft-shell clams that could be then seeded on flats in communities here in Washington County. It would also serve as a place for kids to come and for clammers to come for understanding more about soft-shell clams, to learn about clams, promoting cooperation and exchange between and within towns. Applied research was always an aspect of this when you're dealing with a commercial species and you're a scientist. Basically, if you're doing something in the field, it has an interest not only to you as a scientist, but it has ramifications for the fishery and those that make their money from that fishery. Training people in aquaculture techniques, strengthening relationships between the university and the community, and seeing if we could not stimulate a similar diversity along Maine's coast. We got started on Perio Point. That's as you're going over the Bealls Island Bridge and you look down to your left, you would have seen this structure that you see in the upper right-hand corner. That building is now no longer there. It was torn down this past December, but back in 1986, we had an agreement with Albert Carver and his father, Richard, that we would use this old clam shucking house on this wharf in Bealls Island, and if we got the grant, we would transform it into a hatchery. Well, what we did was we got the grant. We invited 6 towns to participate. Each contributed $500, and at that time, that was quite a bit of money for this particular project. And we found out in September of '86 that the grant came through. This is what the building looked like. It was a general store. It was a clam shucking house. It was also, in its former condition, it was a post office as well as a ferry depot for people that were coming across on a auto barge from Jonesport to Bealls and back. So it had a lot of uses along the way, but it was in a pretty sad state of disrepair. And we created this or developed this Bealls Island Regional Shellfish Hatchery. And the first year in '87, we had a small greenhouse that we used to crudely culture algae to feed the clams. And these same species are what we're using at DEI today. And as I said, it was very crude in terms of the way in which we approached it, but it worked. And we were able to use that small greenhouse to grow algae, different species in a mass culture scenario. And the first time that we spawned clams was June 6, 1987. Everyone knows the date in which their children were born, so do I. This was June 6, 1987, first spawning. This is a male clam, and this is the offspring, what they look like. So I could be showing you a picture of an oyster, a mussel, a clam, just about any bivalve that's in the marine environment. And for the first 10 days, they almost look identical. But when softshell clams settle to the mud flats, they're smaller than a grain of sand, and they're crawling around just like these clams are, and they're 1/5 of 1 millimeter. So for those of you that know microns, these are anywhere between 200 to 250 microns, between 1/5 and 1/4 of a millimeter. And so we grow them in these in the hatchery there on Bealls Island until they get to be the size where they'll remain on window screening, and then we transfer them to Mudhole Cove out in the Eastern Bay, a nice protected environment for them to just sit there and feed on natural algae. This is another view of Mudhole Cove. And then the idea was to enhance flats with the clams that we grew, and that's what we did. We seeded these clams in the fall of 1987, and then we continued in 1988. We found that our bottleneck was raising algae, and so we were able to get a grant through the Maine Science and Technology Board, and it's now called the Maine Technology Institute. This was a 14-foot tall by 20-foot wide by 50-foot long greenhouse that we put up over the summer of 1988. And the idea behind the greenhouse was simply to grow more algae and populate this with a few more tanks so that we could raise more clams. In 1991, we got a grant from Maine Sea Grant to develop a small education center that we named the Dana Wallace Education Center after a fellow that worked for the Department of Marine Resources for many, many years, who was also known as Mr. Clam. And we couldn't think of a better title for our education center than Dana Wallace. And it was a place where, school buses could come in and kids get out, and all of a sudden they were able to look at these larvae and these juveniles and our algae under the microscope, or they could watch videos of some of the things that we were doing in the hatchery. And for the first 8 years, this project was a University of Maine at Machias project. And then in the middle of February in 1995, the president of the college came into my office and said, "Brian, we're out of the hatchery business." And that's when folks like Jane Hinson and Diane Tilton and Wendy Beal and Lynn Alley, they all stepped up and said, "Geez, we can't see this hatchery project go down the tubes. Let's actually try to create a nonprofit." And with many, many, many people helping, in December 1995, the 501c3 status was granted to the board of directors of the Bealls Island Regional Shellfish Hatchery, whose mission was to enhance Maine softshell clam and perhaps other marine shellfish stocks through aquaculture and applied research, technology transfer, and public education. By 1999, the board of directors of the Bealls Island Regional Shellfish Hatchery had larger visions in its sight. And one of those visions was to transform that building into what would become the Downeast Institute for Applied Marine Research and Education. We simply call it the Downeast Institute today, but its real moniker is for Applied Marine Research and Education. And this is an artist's rendering of what we thought was going to happen at Perio Point. We knew that the Downeast Institute someday would become a place where we could grow not just clams, but urchins and scallops and other commercially important shellfish. Again, this was in December of 2000. We wanted to create a marine science field station for the University of Maine at Machias, where students and faculty in marine biology or even rec management could use it. A center for research activity along the Downeast coast. you know, from 1987 to about 2000, it was kind of lonely in Washington County being a marine scientist. And I would ask colleagues, why don't you come and do research down here? Well, there's no place to hang your hat. There's no place for our students to come in from a journey on the mudflats or the rocky shore, and then go to a classroom where they could, learn a little bit more about the things that they had discovered. So there was no place like that. So this would become this center. It would also become an incubator for entrepreneurs, a business incubator. And then finally, a regional learning center for K-12 students to learn about marine organisms. Well, that vision continued into the 2000s and beyond, but it didn't happen at Perio Point. It happened at Black Duck Cove, about 3 miles south on Beal, on Great Wass Island. We were asked by the carvers essentially to leave Perio Point. Lobster landings were expanding, their markets were growing, and they needed the wharf and they needed the building to increase their business. So they gave us about 1.5 years to figure out, where we wanted to go, and we looked at places in a 25-mile radius around Machias. And Diane Tilton had suggested, after taking a trip down to Black Duck Cove and seeing the facility down there, asked if we might just take a look at that and try it out. So we went down in August of 2001, found an 80-foot by 80-foot building that had been built in 1997 with a lobster on the top, because it was a short-term holding center for lobsters. Unfortunately, the folks that bought it, not bought it, but built it, and also bought the land, they went out of business after about 2 or 3 years. And so the building was vacant, and it was trying to be sold. And we cut a deal with the folks in Portland that owned it, that we would rent it for $1,000 a month and put that $1,000 a month towards the purchase price of that building and land. There was about 11 acres and about 2,000 feet of shorefront property, mostly rocky shore, 2 tidal impoundments, and a wharf. It was a lobster buying business. When I looked at it, I took those 7 bullets that I just showed you and said, oh my gosh, what a place to renovate, to become a shellfish hatchery. Wouldn't this be a great place for students if we could build a classroom? And all this stuff, it was just amazing. It was 80-foot by 80-foot, 2 stories. The Bealls Island Regional Shellfish Hatchery was 40 feet by 20 feet, and it was a mess for most of the time. This was like walking into the Taj Mahal. It was wonderful. And we renovated it and started to grow not only soft-shell clams, but we ventured out into other species. And I'll talk about those other species in just a minute. We did have some interesting times. This was the winter of 2004. And if you'll notice, the end of that wharf seems to have a little bend to it that's heading towards the water. And within about 6 or 7 years, we lost the entire wharf. But we gradually found some funding that would help us replace it. And replace it we did with a wonderful structure that's 100 feet long by 30 feet wide, that's built out of fiber composites and cement. And it is a solid force that has a life of over 80 years. We use it for getting our seawater in, as well as other projects we do on that pier. Our first build out of the 80-foot by 80-foot building was a surprise to me. I always thought, well, we really want a marine research facility, and we might want to have an augmentation of our hatchery. But as fate would have it, there was a funding opportunity through the National Science Foundation, and we were able to build a classroom. And that classroom started in July and June of 2010. And by May of 2011, here's some folks from the Bay Ridge School down in Cutler that got a chance to break it in. And here's some more folks from Jonesport and Bealls Elementary who were breaking it in. And since 2011, what's been wonderful is that we've established just a beautiful education program that's run by our director, Colleen Haskell, and Lynn Alley now, our board chairman of the board. And Lynn and Diane, Lynn and Colleen have been working their tails off to try to create new opportunities for students. And before the pandemic, we were bringing in 6 or 7 different elementary schools, between November and or actually between September and May, and they would be coming in every week. In fact, for the past 5 years, even through the pandemic, the students from Bealls Island Elementary, the entire school comes to DEI on Wednesdays, not as an entire group, but in busloads of 2nd and 3rd grade coming from 8 to 9, or 5th and 6th graders coming from 10 to noon, etc. But by the time that they go home, everybody in the school has come to DEI for their educational experience for that particular week. It's just wonderful. I'm so delighted to see that. Well, our goal came about as a result of just some really good luck. Finally, we knew what we wanted, but we didn't have the $6.8 million to pay for it. But between 2014 and 2016, with Diane and others on the board and myself, we were able to cobble together quite a bit of funding to put this facility together. And so we started in the summer of 2017 with the first part of the build out. And this is, again, an artist rendering of what it's supposed to look like, and the floor plans here. We've now created a larger place to raise our algae for the Shellfish Hatchery. There's our education center. We have a lobby that's got a beautiful touch tank in it and conference room adjacent to it where Robert Beck's paintings are being displayed. We've got office spaces for those people that want to come and need to use an office. There's plenty there. We've got lab spaces. We've got business incubators. We've got an ecology wet lab, as well as an ocean acidification lab and a quarantine lab, a walk-in cooler, a place to grow scallops and sea urchins. We call it our boreal culture room. They require colder water, and we can't raise them the same way that we do soft shell clams. And then we also were able to get funding through the Alphon Foundation. I should say that the 3 major funders of this project were the Next Generation Foundation of Maine, the Alphon Foundation, and Maine voters through a 2014 Maine initiative, a bond issue that allowed us to do all of what I'm showing you here today. This is the dormitory where people can come and stay with their students. Here's one of our labs. This is the mezzanine area for our algae raising. And now, remember that, with that Coleman stove that I just showed you a few minutes ago, the difference between 1987 and 2022. There's the dorm from the Rocky Untitled below it. And there's the common room. This is not an artist rendering. This is actually a photograph of what you see when you look out from that common room. And I guess this is most of what we would call the Downeast Institute now. And our species that are under culture. I just want to say that when we look at whether it's a soft shell clam or a European oyster or an Eastern oyster, we have essentially a line of where we want to go. And essentially, this is the Downeast Institute for Applied Marine Research and Education. So we start with research, we then go into the development phase, we involve community people, fishermen, and then we get into the commercialization phase. And all the species that we have are somewhere along that continuum. Just showing you real quickly here, the species that we are now culturing at DEI. So in the upper left-hand corner, so I'm going to go A, B, C. We have blue mussels. B are European oysters. C are soft-shell clams. D is the eastern oyster or American oyster. E are Arctic surf clams. F is Atlantic surf clams. G is razor clams. H, scallops. I, quahogs. And J, lobsters. We actually can grow lobsters at DEI. And one of the other important aspects of what we do at DEI is that we, 2 years ago, were able to bring on a postdoc who's a marine chemist, a marine carbonate chemist, whose forte is ocean and coastal acidification. And he constructed this ocean acidification lab at DEI. So I'm going to stop right there and hope that I didn't bore too many of you with that brief history of the Bealls Island Regional Shellfish Hatchery and the Downeast Institute.
It's very impressive. So I guess the key question is, sort of jumping, you ended up with lobsters in your photos of the species that are under investigation. And I think it's fair to say that the question on a lot of people's minds, because you hear a lot of different things, the warming waters of the Gulf of Maine, the reduction in the number of cod who feed on young lobsters, the role of kelp, all the other factors that go into this. What is your view, or what does your research show you is happening to the lobster population in the waters of the Gulf of Maine, off of Jonesport and Cutler and Hancock?
So I wouldn't consider myself a lobster researcher in the sense of the wild fishery. I defer to my colleagues at UMaine, Bob Stenick and Rick Wally, and my colleagues at Bigelow and the Darling Center and the Department of Marine Resources. The reason why we culture, we're not doing it right now, but the reason why we culture lobsters is for two reasons. One, we know how to do it. We developed a technique way back in 1986 when I helped some fishermen down in Cutler create a lobster hatchery in the basement of their town hall. That was a project that went from 1986 to 1992. The idea there was to release these animals to the wild to enhance the fishery. And it turned out that it was impossible for us to tell whether or not we were having any effect on the fishery. So, because when you release these animals, they are only the size of a penny from the tip of the claw to the tip of the tail, and it's very difficult to mark them. And so the research that we did at DEI in the early 2000s was take these small animals and try to get them to a size where you could actually physically mark them or tag them so that they would be recognized by fishermen or scientists without having to do genetic studies that would require, if you will, fishermen to believe in scientists. When you see a tag, you know that it didn't get there by itself and that would be a cultured lobster. So my knowledge about the fishery is not direct, it's indirect. But it's been interesting reading the papers by those colleagues of mine and talking with them. I'm going to share again, just briefly. Let's see here, right there. I share with everybody just a quick shot of some information that I shared with Stephen a few weeks ago when he visited me in my office about lobsters. Let's see. Let's see from the current slide. Oh, that's not what I want to show, but anyway, I'll get there. Oops, that's the one. Can everyone see this? Yep. So this is a shot that takes a look at lobster landings in Maine from 1990 to 2020. Yeah, 2020. And I've divided the state into 3 sections, and you can see that. So it's landings in metric tons on the vertical axis and time in years on the horizontal axis. And yeah, there's been an increase of lobsters in the Southwest since 1990. There's been a gradual increase in the mid-coast, going down a little bit, but the place where lobsters actually are, the highest in terms of their landings is in eastern Maine. And I've given eastern Maine quite a scope. It goes from Stonington to Lubec. So that is another reason why those landings appear to be much higher than other places. But what's interesting, and so now I'm going to go back in time, if I can get my slide to shoot back. Yeah. So if I go back to there we go. Yeah. So this is a graph of what the lobster landings are from 1930 to 2020. And you can see that sometime around 1990, something happened. Something dramatic happened. And it wasn't that people were putting more traps in the water, although the number of traps was increasing gradually. And for the life of me, I can't figure out that it had much to do with any of the kinds of management programs that were in place, simply because there were egg-bearing females being tossed back. There was a V-notch program. There was a short measure and a large measure. There was escape vents of traps. All of those measures had been in place for many, 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 many years before 1990. And then all of a sudden, something skyrocketed. And at the same time that this was happening in Maine and New Hampshire and Canada and Massachusetts, Connecticut and Rhode Island were losing their fishery. They were losing their fishery, and it was related to how warm the temperature of the water was in places like Narragansett Bay and Long Island Sound. And if we take a look at the temperature increase in the Gulf of Maine, I'm sure that most of you have either read or heard about that the Gulf of Maine is warming at a faster rate than 99% of the world's oceans. And that's been going on, and that's been happening for quite a while, not just since 2015, but it's been happening basically since the late 1980s. And this increase in seawater temperature has resulted in a variety of things that lobsters are key to. And one of those is reproduction. So as a stern man for a friend of mine, Harry Beal, and as a grandson of a guy that went out and lobster fished out in the Eastern Bay in the 60s and 70s, what I would notice from lobster traps is that when you brought up a trap, it had, a 2 or 3 pound lobster that might have eggs. You wouldn't see any eggs on animals that were less than 2 pounds. And in 1986, the fishermen in the Cutler Hatchery saw something that they'd never seen before. We got permission to bring lobsters from Long Island Sound because they were egging out earlier in the year, and use those as some of our hatchery stock. And when they arrived in Cutler, every lobster fisherman in that community came into that hatchery and looked at something with their mouths wide open because they'd never seen it before, which was a 1.25 pound lobster with eggs. And it turns out that warming temperature helps to increase fecundity, especially increasing it earlier on in their life. So this warming temperature has resulted in the same phenomenon here in the Gulf of Maine. You can go out now and find animals that aren't even a pound that are reproducing. So there's a lot more eggs in the water column. And they're growing at faster rates because the water temperature is a little bit warmer. What we don't know is what's going to happen in future if we continue this trend. I think it will be quite some time before seawater temperatures ever get to be what they are in Long Island Sound and the Narragansett Bay, if ever. But seawater temperatures definitely are increasing in the Gulf of Maine, and that has implications not only for the lobster fishery, but for other fisheries as well. I should also say that during the time that these lobsters have been increasing in their landings, there's been other organisms that have been fished, and their story intersects with or interacts with lobsters. So here's a quick story about sea urchins, for example. There wasn't a fishery for sea urchins in 1987. There was about $100,000 fishery, which was basically nothing. I remember going into the Eastern Bay with my grandfather in his lobster boat on low tides and looking down at huge ledges at the opening between Pig Island Gut in the Eastern Bay. And we'd look down and there would be thousands and thousands of green sea urchins on these rocks that were barren, that didn't have any kelp on them. Because the second a kelp would settle on those rocks or those ledges, it would get eaten as a small morsel by these sea urchins. Sea urchins are herbivores, they're grazers. But look what happened. This fishery went from nothing in 1987 to almost $45 million, or about $40 million by 1994, and then it dropped off again. There were so many urchins that were harvested, and you can see that they haven't rebounded. And what's happened as a result of the lack of a rebound is that there's tons and tons of kelp in places where the urchins were chewing it down to if you will, bare rock. That kelp is a habitat for lobsters. They hide in it, and it helps them when they shed to hide from predators. So here's an interesting scenario where we have this herbivore that was grazing lobster habitat down to nothing, and now the urchins are basically, there's hardly any out there comparatively speaking, and there's now tons of kelp. Stephen mentioned earlier that the cod fishery has gone down. Cod's a huge predator of lobsters, so that's happening at the same time. It's really amazing. It looks to me as though temperature is the driver, commercial fisheries, and in this case, serendipity, when folks discovered how many urchins that we had, and I would say that nearly 95% of these urchin gonads, or uni, was shipped to Japan. I was in a Tokyo fish, not market, but fish auction in 1997. I'd gone over to learn about sea scallops, but we were taken to this place in Tokyo, this auction, and I found myself in a room where the auctioneer was auctioning off uni, or urchin gonads that were in these wooden boxes. And I looked up on the shelf, and there were boxes stamped Jonesport, Maine. And I was just, flabbergasted at that. So that's just a quick story about lobsters and urchins and how those interact, along with temperature, as really the driver that's happening here.
There's a lot of complicated factors that probably explain partly why the lobster population boomed, and maybe also why we've seen a slight downtrend in the last couple of years. But can we move on to your life's work? You're a clam guy. You're Mr. Clam.
Yeah.
And I have a personal interest in mussels too, because our house in Jonesport is near the Great Bar. And when we first moved here in 2002, you could walk out on the Great Bar at low tide and gather buckets of mussels, pick them right up. Well, that's no longer the case. So I think there's other factors that have come into play here, predators for both clams and mussels. Could you talk about that a little bit?
Sure. So I'm looking on my screen. I've got the house rights just below my face, and so there are folks that I've come to know down in the Freeport area, and I'd say for the last probably 7 or 8 years, I get phone calls regularly, whether they're coming from Freeport or Gouldsboro or Lubec, and it's just exactly what you said, Steve. We've got a place that we can walk down, and we've been bringing in mussels, and we love to eat mussels, and we go down and we could bring back pails full a few years ago, and now we can't seem to find any mussels. What's going on? Well, I can tell you that mussels aren't going extinct, but they are going extinct in the intertidal zone. And they're going extinct in the intertidal zone because of green crabs. And it's pretty easy to tell why. So there's a dock that is on the water below where the house rights live in Freeport. And I work there when I'm down there. It's a clammer who actually owns a floating dock that has an upweller, and he's growing oysters. And if you look on the underside of that dock, or you look at ropes that have been suspended from that dock for a while, it's loaded with mussels, just tons and tons of mussels. Whenever he wants to get mussels, he just goes and gets on his belly and scoops them up and puts them in a pail and takes them home and eats them. But the rocky shore that's adjacent to this area doesn't have a mussel on it. And the same thing has been seen in other places. I took a picture last October of a boat that had been hauled up down in Gouldsboro. And I guess they forgot to use copper paint on the bottom of it because it was just loaded with mussels. So the observations are that mussels are in the water column. They have to be, as larvae swimming around. They're looking for something hard to settle on, like the bottom of a boat or a piece of rope or a piling or a rock. But when they land in certain places, they don't grow up to be adults. And what's happened is that as the water temperature has increased over the course of the last 15 years to a point where it's now heaven for this invasive species called the green crab. And what's happening is that green crabs, it turns out that they're members of the family Fortunidae, which are crab species that actually swim. So if you're familiar with blue crabs in the Chesapeake, green crabs are related to blue crabs. They're in the same family, but they're the only one in that family that doesn't swim. So they crawl, and they crawl, but they can't get up in the water column. So if a mussel lands on the underside of a boat, it's a refuge. We call it a spatial refuge from predation. But if that mussel lands somewhere in the intertidal, whether it's a mud flat or whether it's a rocky shore, there are thousands and thousands of green crabs that are smaller than your pinky nail. I'm talking about animals that might be 4 millimeters or 6 millimeters, quarter of an inch in size, and they're the ones that are having the largest effect on recently settled mussels. So when mussels spawn, they put their eggs and sperm into the water column, just like soft-shell clams, and they have a planktonic phase, which I showed you some microphotographs of before. They settle at sizes that are 1/5 of a millimeter. Green crabs also have a planktonic life cycle, and when they settle, they're 1 millimeter. So 1 millimeter is 5 times larger than a settling mussel, and they're voracious. So 1 millimeter crabs are eating 1/5 of a millimeter mussels, and it's happening in places where, you know, the mussels ordinarily would be thriving, but there's so many green crabs. And last year we saw more green crabs in one of the other projects that I'm doing is looking at clam recruitment. And I'll explain that in just a second, but we've been looking at green crabs settling onto mudflats, and last summer and last fall I've never seen so many green crabs. Real quickly, we've got wooden boxes that we put out on mudflats that are 1 foot by 2 foot that are lined on the top and the bottom with a very fine mesh that small green crabs can actually get into. They're 0.7 millimeters by 1.9 millimeter mesh, so it's a pretty small mesh. But clams can settle through the mesh, and they go into these boxes, and if there's no crabs present, some of these boxes sometimes get anywhere between 3,000 to 6,000 clams, which is pretty amazing. So we've been using this mechanism to look at recruitment of clams all up and down the coast. We are working in 9 communities from Sabayak up in Cobscook Bay, all the way down to Wells in York County. So we're spanning the coast. We've got 3 sites in Washington and Hancock County, 3 sites in mid-coast Maine, and then 3 sites in the southern part of the state. And I've never seen so many green crabs. We've had some boxes that had 40 and 50 green crabs the size of your thumbnail in them, and just tons of small clams that have been chewed up and consumed. So what's driving the green crabs is water temperature. So you asked earlier, Steve, about if this winter and the weather that we've been getting is going to take care of this. My contact down in Freeport tells me that when he goes out, he's an oyster farmer in the wintertime. He's a clammer in the summertime, and he's harvesting his oysters right now. And he has gear that's out on mud flats that are only you can only get to them on the spring tides. So that's when there's a new moon or there's a full moon, and that means that the tides go way out or are very, very high. And his equipment to raise the oysters in is quite down low in the intertidal. And he flips these bags of oysters over, even at temperatures of 10, 12 degrees, and the green crabs are just crawling out from underneath the cages. So I don't know that if we were to get 3 solid weeks of 0 temperature, I think we could raise the flag and say, we're going to have some clams and mussels back again. But what's happening is that we get 2 days of 0, and then it's 40 degrees. The Gulf of Maine, the temperature of the seawater, I've been watching it on the weather forecast every night, it's 42. 42. That's about the highest temperature that it's been in February in an awful long time. So even though we have gone through these spells of extreme cold and even seen ice build up in some of the coves, the overlying water coming in is kind of like an insulating blanket. And I'm wishing that this cold air will result in the deaths of green crabs, but I don't know. They're pretty hardy. Listen, they've been in North America since 1817. They got here from the British Isles accidentally in the hulls of ships that used rocks that had rockweed, the same rockweed that we have here. Though the rockweed was used as ballast in those new ships. And they came over to North America. And sometimes they weren't in good shape when they landed, and they ended up just, dissolving on the marshes. And those rocks that had seaweed on it had green crabs, and the green crabs came out. And this was happening around Long Island, they figure, in 1817, and then they went north and south. And green crabs were first discovered in Casco Bay in Portland in 1905. It was not until 1950 or 51 that they were discovered in Washington County. And they got there the same way. They got there on, by ships. In the hulls of ships, or transferring lobsters and seaweed that was used as packing in these vessels. It wasn't until 1957 that they were discovered in Nova Scotia, and it was in the 1990s that they finally made it to Newfoundland. And there's a thriving population there. So Newfoundland's pretty cold in the wintertime still, but green crabs survive there. So we'll see, but they're awful. And I'd say they're probably the second most important driver of clam populations and mussel populations, water temperature being the first.
Well, I know we've got questions that have come in on chat, and I invite anybody who hasn't had a chance to ask a question to do that now. So I'll turn it over to Jim and Jackie and to ask some of the questions that you all have had.
Dr. Beal, this is Jim here. I'm going to ask a question that Barbara Snap put in the chat. She asks, how long does it take for one clam offspring to mature to release?
One clam offspring to mature to release. Okay.
That's her question.
Yep. So the answer is it depends. It depends on where that clam lands in the intertidal. So we go clamming on mudflats. It turns out that clams, when they spawn, the offspring can go anywhere. They can go out 3 miles, or they can go to the upper intertidal. And it turns out that they're so, they have little mechanism for surviving other than growing fairly quickly and burrowing in the mud. But what we find is that if they are in the high intertidal, they survive very well, but they grow very slowly because they can only feed when there's water over them. So, for example, if you are familiar with the Great Bar or Flake Point Bar in Jonesport, the high water mark, you can find clams pretty close to the high water mark, and it might take them 7 to 8 years to reach size where they'll actually reproduce, if that's your question. But the further down that you go in the intertidal towards the subtidal where the water is always, their growth rates are much faster. A place over in Addison, down near Eastern Harbor, we put clams that we grew in the hatchery that were about 1/4 of an inch. We planted them in May of 2002, and by November of 2002, 10% of them had reached 2 inches. And no one had ever seen that kind of growth rate before. We planted them very, very low, but the trade-off for clam is that the lower they are, the higher the rate of their mortality. And the reason why they don't survive very well in the lower intertidal is because predators are going to eat them. And so there's very, very, very few clams that you would ever encounter if you were a diver and you were off 3 miles. You might find some clams out 3 miles, but not very many. So it all depends on where they settle as juveniles, as to how fast they grow. And then as we go from one end of the state to the other, of course, it's warmer down in the Freeport and Wells and Biddeford and Scarborough area. And so clams grow much faster down there. In fact, I would say that in places in the Harriseket River that Kim and Elizabeth look out over from their house down in Freeport, then in the upper ranges of the Harriseket River where it's pretty warm, that clams can settle and grow to commercial size 2 inches in less than probably 16 months, which is pretty fast.
Thanks.
There was a follow-up question that when you're when even for commercial species, Barbara asked, are you releasing them all as juveniles, or do you hold some on till they're larger?
No, we can't hold them until they're larger because it costs so much to bring them to those large sizes that we just don't raise enough algae to do that. So what we try to do is for clams to get them to a size that's around 1/2 inch. And that takes us basically from, well, we're spawning clams in the hatchery today at DEI, and those clams will be the size of window screen by May. So they've gone from, well, an egg is 41,000th of 1 millimeter, and window screen size is about 3 millimeters or 3,000 microns. So we go from 40 microns to 3,000 microns from essentially February to May. And then it's time to move them. So we build these wooden trays and we line them with window screening, and then we put the clams in those trays and move them out to this cove, Mudhole Cove. And it takes them, in Mudhole Cove, it takes them from May until November to get to be that 1/2 inch size. The fellow, I keep looking at the house rights, but the fellow that I've been working with in Freeport that has this place on his float that he can put clams in, and the water comes up through the silos that the clams are in and exits. By the time it exits, the clams have fed on all of the algae that's naturally in the water. It's called an upweller. Well, we can put the same size clams, those 3 mm clams in that upweller in June in Freeport, and by August, they're 1/2 inch. And by November, they're almost 3/4 of an inch. So that gives you an idea of how fast these things can grow, but also the effect of water temperature. Because the water temperature in Bealls Island doesn't even get up to 68 degrees. It can get up to almost 72 degrees down in the southern part of the state. And if it gets to be 58 or 59 down east, that's pretty warm.
Thank you. There's lots of interest, Dr. Beal, in the green crabs, and many of the listeners tonight have questions about that. Roy Nealon's asked, do green crabs have any predators? Other listeners ask, can we eat them? Can we help that way? Could you speak about that, about
Sure.
enemies of the green crab? Thank you.
Yes. So one would think that an invasive species would have no predators, but it turns out that everything eats green crabs, including green crabs. They're eaten by fish, they're eaten by ducks, they're eaten by other crabs, they're even eaten by lobsters. But what they have going for them, and the reason why they make the top 10 in the list of 100 invasive species globally, they're in the top 10. What makes them that invasive is their fecundity, how many eggs that they can produce. And an individual green crab that's about 2 inches in its carapace width is producing about 185,000 eggs. And, you know, it doesn't take an awful lot of green crabs at 185,000 per individual to build up a population. And, you know, there's been this idea that we can eat our way out of them. And quite frankly, about 5 years ago or 10 years ago, I thought that maybe that was the case. But we fished in the Brunswick, Freeport, Scarborough area. We fished green crab traps for an entire summer and fall. And we would remove from 20 to 25 traps, anywhere between 200 to 400 pounds every 2 days. And by November, we were getting 300 to 400 pounds out of the same traps. So, you know, if a crustacean like a green crab could be trapped to death, that'd be great. But it would take a fishery larger than the lobster fishery to put even a dent in any green crab. You know, people are going around and they're eating green crabs, which is fine. They taste great. In fact, I used to pick crab meat out as one of the things that I used to do to earn my tuition dollars at UMM. So I'd sit in the basement of my house in Jonesport and sell the crab meat to my father, who had a truck that drove down to New York every week, and I'd get $5 a pound for picking out crab meat. So I'm pretty good at picking out crabs. And I've picked out green crabs and eaten them, and they're good. They're really good. In fact, I bet you that if I took a rock crab and a Jonah crab and a green crab meat and blindfolded you and had you taste them, I don't think that you'd be able to tell the difference between a rock crab and a green crab. They taste pretty much the same, and the texture of the meat is almost identical. It's not sinewy like the Jonah crab. Nonetheless, they're so fecund that you're just not going to do anything to get them to mitigate their effects on clams or mussels or anything like that. The idea is to create a soft green crab, but the mechanisms that the green crabs use to shed are not exactly the same as its cousin in the Mediterranean, where people over there for centuries have been producing a shedding. It's a green crab. It's the same genus, but it's a different species. It's Carcinus. And it's apparently wonderful. And folks from Italy and from Greece have come to Maine and Massachusetts and New Hampshire to try to help people in the shedding process of these green crabs. And nothing really has worked very well. So There's no way to eat their way out of it. And there's only, that I can see, one mechanism that's going to have a dent in green crab populations, and it's the weather. And if we don't get cold for long periods of time, we're going to see more and more and more green crabs.
Brian,
Yes.
can you do something? We have a question here about trying to project out about, like going forward 20 years from now. What kind of changes do you believe you'll see in the shellfish industry and lobsters and so forth over the next 20 years?
Well, I have to think that aquaculture is going to play a major role in fisheries in the next 20 years. I think that it will be much longer than 20 years where we'll have to be worried in the eastern part of the state about lobsters. I think that we're going to have a strong lobster fishery for some time to come. I don't think that we're going to see the kinds of water temperatures, at least down east. It'll take much longer than 20 years. But in other parts of the state, maybe in the Casco Bay area, they may be looking for help. I would like to see aquaculture of lobsters, but I don't think that that's a thing that's going to buy much public support, especially from the fishermen at this point. We can grow lobsters. I also think that we're going to see a lot more shellfish farming. Here at DEI, we're looking to take 70% of the coast of Maine is producing about $7 million worth of oysters every year. And those oysters stop at somewhere around Taunton Bay commercially. They can be grown in lobster pounds, but if you take them out of lobster pounds and you put them in Lubec, or you put them on Bealls Island, or you put them in Millbridge, it takes those oysters 7-8 years to get to be the size that they get to be in 3 years in the Damariscotta River, for example. So at DEI, what we're doing is the same kind of thing that was done in the 1970s through the University of Maine with oysters. There wasn't a fishery for oysters in 1970, but someone said, geez, there used to be tons of oysters. We know that because of all these shell heaps that we see along the coast, especially in mid-coast Maine. So oysters are a traditional species dating way back when. So they took oysters that came from Long Island Sound, and through selective breeding, they selected for a fast grower in the colder waters of the Damariscotta River. And from there, 2 commercial hatcheries are in business today, producing almost all of the oysters that are raised in the state of Maine. But someone in Lubec or Bealls Island or Cutler or Millbridge or Addison that wants to do that can't, because even though they were selectively bred for the cold waters in Maine, they weren't selectively bred for the really cold waters in Maine. So what we're trying to do down east, and we don't know, I mean, this is, for me, this is the coolest thing about DEI. It really is. We can, with grant funding, of course, we can take those risks that other people would never want to take and see whether or not something's going to work. So we're working with a selective oyster breeder from the University of, well, actually it's at Morgan State University. It's in the middle of Baltimore. And this fellow is an oyster geneticist, and he's working with us to try to see if we can do something genetically to selectively breed animals, so that if anybody wanted to grow an oyster in a few years in Downeast Maine, perhaps we can do it. That's a project that's going to take some time, but it's one of the things that makes DEI so special, is that we can step out and do these sorts of things. But to answer the question, I think aquaculture is going to become a lot more prevalent, and I'd like to see aquaculture occur in the intertidal zone. But it's not happening right now for a variety of reasons that date back to 1641 and the colonial ordinances of Massachusetts that gave the property of the intertidal to the shoreland owner. so that if somebody like myself wanted to put a clam farm on a mudflat in Jonesport, I would have to get permission from the riparian owners because they own the intertidal. But I would ask anyone that is a shoreland owner in Jonesport or Bealls or Machias Port like myself, how much taxes do you pay on the intertidal property that you own? And if you're like Machias Port or any of the other towns, there's no charge on those flats that you own. So there's no clam farming in Maine right now. And the reason is because the intertidal is owned, it's privatized. And I'd like to see it not be privatized because I think that that would add a lot of income to people up and down the coast.
We're past the bewitching hour here, but I think we've got time for one more question. Jim, if you have one from your list.
There's many questions in the chat, but let's get back to one of those dramatic slides you showed, Dr. Beal, the rise and fall of the sea urchin population. Barbara asks another question. Why haven't sea urchins rebounded? They were so high in the mid-90s. What has happened to that population? Can you discuss?
Yeah, well, I can discuss, but I can really hypothesize because I honestly don't know. And I don't think that there are very many people that know. Here's the deal. They spawn and they release their eggs and sperm into the water column. And like mussels or clams or oysters, all the development occurs. What's happening is that when they're settling, they're not surviving. And whether or not that's because they're being eaten or there's just not enough, we don't know. But what we see is a population that's struggling under the conditions that occur right now. Look, there's so many lobsters out there and there's so many crabs. And what do crabs and lobsters feed on? Basically anything that they can get in their mouth that's big enough to eat. And you know, an urchin that's this big is a you know, it's like you and I eating a Hershey's Kiss. They love it. So there's tons more lobsters. There's tons more crabs than there used to be when the urchins were, you know, the populations had exploded. And you know, when you look at that dramatic, that's a fishery. And look at that high level in like 1995, 1996. Think of all the hundreds of thousands, millions of urchins that were out there before 1996. No one was harvesting them. So for forever, people were, you know, they weren't eating urchins. You know, you know, people down here in Downeast Maine, they call them whore's eggs. No one wants to eat an urchin. Who would ever think of eating an urchin? So, you know, it's kind of like mussels. Until 1970s, I can remember my grandfather learning for the first time that someone was eating a mussel. And he, you know, he felt badly because they were impoverished. Who would even think of eating a mussel? You know, and today, my God, people want mussels more than they do oysters in some towns. So anyway, the answer is something's happening to the animals when they settle. And you know, the paradigm that I live in and have lived in for a long time, and I try to get out of it as a scientist as best that I can, is predation. And you know, it really looks like predation is the regulating mechanism for many of these populations, unless you're an invasive species and it's weather.
Well, Dr. Beal, this has been fascinating, and it's great to hear about how the Downeast Institute has developed over the years. It's a very impressive facility. When we have guests from out of town, we always bring them over to the Downeast Institute. People are so friendly and helpful when you go in there and ask them what they're doing. But we have reached the end of our time. I ask everybody to join me in saying a hearty thank you to Dr. Beal for this wonderful presentation.
Thank you. Thank you. I want to give one shout out before everyone leaves. I want to give one shout out, two shout outs to Jane Hinson and to Diane Tilton. Jane Hinson and Diane Tilton are the rocks of DEI. they've been there since the beginning, especially Jane. She edited my first grant, and I've got a copy of all of her red marks that she made all over the paper. And I incorporated all of those things into that grant, and I got it. And so from 1986 until about 1996, every grant that I wrote went through Jane Hinson's office at UMM. She was the director of outreach and special programs, and a wonderful editor. And then, of course, Diane, who's our executive director. Diane's an all-star, and DEI is not looking anything like DEI looks today without Diane Tilton. And so big hugs for Diane. Anyway.
Thank you so much.
Well, thank you, Dr. Beal.
And thank you to everybody who joined in tonight. This was great. We might have to do it again.
Yeah.
Get to all the rest of the questions. Thank
Thank you,
Dr. Beal.
Brian.
Thank you.
Thank you,
Good night.
thank you.
Good night, everyone.